Uh, Hello guys. Thank you for coming to our Physics 71 LE1 review session. We'll start in a few minutes. Okay. So everything's clear on our end now, so we can start. So firstly, hello ulit everyone. Thank you for coming to IE Club's Physics 71 LE1 review session. Thank you so much for attending and choosing to spend the next 2 hours with us. So, um, before we do anything, make sure you have a copy of the Samplex na i-discuss natin. So we have sent out the link to this yesterday. We will be discussing Samplex B. So we sent out two Samplexes. We will be discussing Samplex B. If anyone doesn't have access to it, please let me know so I can send you the link. But otherwise, I'm gonna assume most people do na. So now we can start. So if you've been to the Math 21 review session, uh, this person is going to be a familiar face. Well, not exactly face because we are online. So di nyo siya kita. But we will be having Jerome again for our as our tutor for this review session. So please give a virtual round of applause to Jerome. And yeah, take it away. We can now start discussing.
Okay, hello. You hear me? So yeah, if you went to the Math 21 review, you're probably tired of my voice. So I hope you have a copy of Samplex B, which is what we're gonna be discussing. And I think I assume, pretty sure now your profs already sent a copy of the list of formulas they're gonna give during the exam, so you can also take that out so that you have something to refer to. And since it's kind of late in the night, what I'm gonna do for the samplex is we'll start with the harder items first, habang my brain function pa tayo. And then after those, I can just discuss the rest if we still have time. So I'm gonna start with number 14, just Deadpool. So Deadpool drops down from the top of a tall building. Takes 10 seconds for him to fall one third of the height of the building. What will be the total time for him to reach the ground from the top? So, best thing you can do, like for every problem, you start off by making sure you know what's going on. So usually pag ganito, I like to make a little drawing. So, um, and one of the keywords here is he drops down from the building. So it's not like he jumps or so the word drops specifically is used to indicate that the starting velocity is zero. So he's just falling off the building basically. And then we also have a given time equals 10 seconds, but this is for him to drop only one third of the height of the building. Like if this entire thing is the height, this thing is only one third of the height. Ano pala, if you ever have any questions, just feel free to chat them. And or if like there's something wrong with my audio or the stream, pa-chat na lang din. Thank you for your cooperation. So what we're gonna use for this problem is one of our favorite kinematic equations. Well, one of my favorite. Sorry, I don't know if that's weird to say. I have a favorite kinematic equation. So y equals y naught plus UIT 1/2 AT squared. So this is used in basically most problems with constant acceleration, where sometimes it's not y, sometimes it's x, or sometimes they use d and d naught. So in this case, our y naught, we're going to be from the top of the building. So y naught is equal to h, the entire height of the building. And then y, which is going to be like our final or the final height, quote unquote final. In this case, height after 10 seconds. Since we dropped one third of the height, then our height after that is going to be two thirds of the height. And then our VIT, which is the same as V naught, is zero. Then our T is 10 seconds, and then our A. Sorry, A. Oh, first it's 9.8 meters per second squared. So what we're actually going to do here, we have all of these, wait, let's try to laser count on this. So since these are the variables we have, our unknown here is actually the height of the building. So first we're going to solve for the entire height of the building so that later on we can solve for what the final question is asking, which is the time it takes to reach the ground from the top of the whole building. So basically we just substitute what we have. 2/3 h equals h plus, then our v naught is zero, so this whole thing is zero. It's 1/2 at squared, 1/2 1.8 meters per second squared. 10 seconds squared. So if you have the nice calculators, actually I think most standard cycles naman have yung shift solve. Basically, ideally, you won't have to rearrange this na algebraically. You just enter this plainly. Usually h will be replaced by x or something, and then you make your calculator solve uh the whole equation since it's just one variable. And you're gonna get h is equal to should be 1,170 meters. So this h is gonna be our new y naught in our new equation where we're trying to find out how long it takes for Deadpool to fall all the way down, meaning our y is zero, which is the ground. So we're just gonna use this Pauli equation again. Substitute what we have. 0 equals 1,470 meters plus 0 plus 1 half, still negative 9.8 meters per second squared because there's no other forces acting. And then t squared. So you can rearrange this algebraically, or you can again make your calculator your slave, make it shift solve, and then you should get p is equal to 17.3 seconds, which in choices is here. Letter B. Was that too fast or too slow? Or are we good? Send a heart react if you're ready to move on to the next item. Wow. Thank you for giving me your hearts, guys. I really appreciate it. I only got 4 heart reacts. I hope everyone is G. But if you're nahiya, you can always message me after or message someone from the fast team or Akadeng. Next item, which is one of the hard items, number 18 and 19. Well, 18 and 19, not really that hard, but uh, it's not really that hard, but it has a lot of steps. That's why I decided to also include it. So number 18, this is the easier between 18 and 19. It's just asking, what's the x component of the velocity at point Q? Point Q is here. You can see it. And then we're also told that at point P, the x velocity is equal to 9.00 meters per second. And then the fun thing about projectile motion is that since the only acceleration or the only force acting on it is gravity, the only acceleration is acceleration due to gravity, which is only downwards on the y component, which means the initial velocity, initial x velocity, horizontal velocity on projectile motion will stay constant all throughout. So from here to here, except probably when it touches the ground because it's going to stop, uh, the horizontal velocity is going to be the same. So the horizontal velocity at P is the same as the horizontal velocity at Q. So since the horizontal velocity at P is 9 meters per second, we know that the horizontal velocity at Q is going to also be 9 meters per second. So yeah, that one doesn't have computation at all. You just have to know how projectile motion works. Number 19, promo. The initial velocity along point O is 10 meters per second. What is the height of point P? Oh yeah, there's actually a typo here, which confused me for a while. So this is supposed to be along y, like along the y-axis or the vertical. So that means that actually this means that v naught y is equal to 10 meters per second. And so since it's asking for what is the height of point P, so usually we would be able to do or we're going to use our favorite equation again, y equals y naught plus VIT plus 1 half AT squared. So we know our A, it's always G, 9.81 meters per second squared. We know our VI, which is which is the 10 meters per second. Then we know that our Y naught is 0 because it's coming from the ground. But the problem is here, we don't know our T. So we actually need to solve for T first before we can solve for the height at point P. So since we actually know the y-axis velocity at P, which is 6.40 meters per second. And we know the initial y velocity is 10 meters per second. And we also know the acceleration. We can solve for the time because Vf is equal to V naught plus AT. This is another kinematic equation that you should know. And It's going to be in the formula sheet naman, but these two kinematic equations are one among the ones that you should just know by heart. And when you, oh my God, when you know those by heart, it's gonna make this unit a lot easier. Like yeah, that's the heart of kinematics. That's why they're called kinematic equations. So first, let's substitute what we have. All right, let's substitute values into this one, being VF plus VI plus AP. So our VF here is 6.40 meters per second equals 10 meters per second plus negative 9.8 meters per second squared times T. Then when we solve that, you shift solve that, or if you arrange it and then calculate it, you're going to get T is equal to 0.3673 seconds. So now we know the time it took to get from point O to point P. And now that we know that, you can also find what the height is at point P, since it was the only variable we were missing for this equation. So substitute again. Y equals, our Y naught is 0, our VIT is 10 meters per second squared times 0.3673 seconds plus 1 half 9.8 meters per second squared. Oof. Okay, I ran out of space. Good thing this is an iPad. Times 0.3673 seconds squared. And then when you calculator that, you're gonna get 3.01 meters, which is, thankfully, it's in the choices, which is the most relieving feeling you can feel during a physics series LE, when your answer is in the choices. Okay. Wait lang. Gumagana pa ba yung stream? Oh no. Wait lang. Wait. Do you guys still hear me? Well, I think my okay, good. But I think my internet on my iPad is telling us to take a short break. Not like literally, just like let this information soak in while I get my stream back up. And just keep sending any questions if you have any. Thank you. Yo. So if di nakita sa last, this is the end. I just wrote out the substituted formula and then the final answer, 3.01 meters. Next among the harder items is number 32. Wow, we're jumping everywhere. Okay, so this one has a lot of steps, or maybe not a lot of steps, just a lot to write down if you want to make sure that you're doing it right. So I hope your professors or instructors have been teaching you that when it comes to problems like this, the first thing you want to do is make the free body diagram free. I don't know if it sounded like I said three, but free body diagram. So let's work on it here. So this is the force being applied. Then we're also going to add the friction. Then we have the normal force perpendicular to the surface and the weight, which is just straight downwards. Then we know that we have an angle here. Angle here, 30 degrees, which means this is 60 degrees. This 30 degrees. So the reason I made these dotted lines, this one along near the friction. Wait, okay. This represents the platform itself. And then the oh wow, it's laggy. Okay. And then this one I'll highlight it now. The one I highlighted in green and the one I highlighted in red. The one highlighted in red represents the platform itself. Then the one in green is the axis perpendicular to the platform because we know that normal force is always exerted by the platform, so its direction is going to be direction is going to be perpendicular to it. Then what we're going to do with this information now that we know the angles, we want to turn the turn the free body diagram so that the platform, we can treat our platform as the x-axis so that it's easier to sum up our forces and stuff. Okay. So, yeah. So this is our nice little free body diagram. Ah, sorry, I don't know why it keeps disconnecting. Yeah. 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 Back to business. So we have the free body diagram I boxed in green, which we're going to use as reference to make our equation. So we want to find out the sums of forces along the axes, um, along the x-axis. Oh my God. Yeah, gonna be friction force. Oh, I didn't label this. This is the weight. Friction force minus the applied force, then plus the weight, the component of the weight force, which is along the x-axis. So we're gonna use our trigonometric functions here. So since the angle is 30 degrees, the opposite of this is gonna be the x-axis. So since it's opposite, the x component of the weight is gonna be W sine 30. And then another important detail, which is part of the problem, is that we're asking about a scenario where the box is gonna move at constant speed, meaning acceleration is gonna be zero. So the sum of force is also gonna be zero. Then sum of forces. Dude. Uh, sum of forces along y be just the normal force minus the y component of the weight, which is W cosine 30. So what do we do now? Since we have these, it's basically a system of equations that we can use to find what we're looking for. So let's go back to the problem. Let's note down our other givens, which is saying that magnitude of the frictional force is 1/2 times the magnitude of the normal force. So our friction force equal to 1/2 normal force. And then what should be the magnitude of F such that this box will move up along the incline with constant speed? So this is what we're looking for basically. But from this equation, the summation of X, what we don't know yet is the friction force and the weight. Not the weight, just the friction force. Sorry. But we know that the friction force is 1/2 of the normal force, and then we can also solve for the normal force here. Normal force is equal to W cosine 30. So if we fill up, if we substitute this summation of x forces along x with the values that we know, going to be W cosine 30, sorry, 1 half W cosine 30 minus F plus W sine 30. And just don't forget that W is going to be equal to 30 times 9.81. Since 30 is the mass of the box, we just need to multiply by acceleration due to gravity. So do all that, put this to 0. Solve for F, or just F is equal to all that. 1 half W cosine 30 plus W sine 30. Then we're gonna put this into your calculator. You'll get 274.59 newtons, which again, thank God, it's in the choices. Letter C. Any questions? Send hard reacts again if you're ready to move on to greener pastures, and hopefully no more randomly stopping of my stream. Thank you. Sa nag-send ng heart react. 819. Next one is 39. Okay. So 39 actually isn't hard like when you solve it, but it might be hard logically. Like you need to know definitions again. It's not like numbers. So a bob weighing W is being acted on by a tension T in a configuration shown on the right. What's the force component directly responsible for the centripetal acceleration? So the crucial piece of knowledge that you need to know here, crucial piece of knowledge, is that the centripetal acceleration, it's usually going to point to the center. So here, since it's moving along around this circle, our center is actually, or a force pointing to the center would be from the ball to this center. So we're going to want to find out, let's draw this free body diagram. This is the weight, and this is the tension. Then this is our angle theta. So we want to find out what forces contribute to any kind of force which is pointing in this positive x direction. Since that is, as you can see here, they're the same. Pointing toward the center is that arrow. Gets? So pretty simple actually. You can see that W is actually perpendicular to this right arrow. So you know that W isn't gonna be contributing. So don't choose C, don't choose D, please. And then from here you just use trigonometry. So since this right arrow is opposite of this angle theta, it's just gonna be d sine theta, which contributes to the centripetal force, meaning forces which point to the center of the circular path. So letter B, letter B. Oh my God, why? Moving on, I hope we're all ready because there wasn't much calculation there. So I think by the end I would move on. Number 40 is pretty hard. Well, the thing, same thing basically. You need to know the concepts here, but the computations themselves is not going to be hard. So a 1,000 kilogram car is making a turn on a curved bike. The car experiences a normal force of 12,760 newtons and a static frictional force of 5,995 newtons as it moves with a maximum speed without sliding up along the bank. If r equals 10 meters and beta equals 20 degrees, what is the car's speed? So this again is another example of centripetal acceleration. So take note first, what are we looking for? Car speed. So what formulas related to centripetal acceleration can get us the car's speed. We know we have this centripetal acceleration equals v squared over r. Looking for the speed, so let's just rearrange it to v equals square root of AC times r. We already know r, which is here, it's equal to 10 meters. So that means the brunt of our problem here is going to be finding AC. So AC is the acceleration due to the centripetal force. And since centripetal acceleration points to the center, we also know that we're looking for the forces which point to the center. So we need to make a free body diagram again. I'm sorry, everyone. So okay, I'll draw it on the picture, Miso. Baka it will help. So this is the weight of the car. Then this is the normal force. And then here's a tricky thing about this problem, frictional force. So we know that there's frictional force, but then on the free body diagram, where are we gonna put it? So when in centripetal acceleration, or like in this specific case of our new car drifting in a circle, our our frictional force is gonna be pointing toward the center then, but it should still be parallel to the surface. So this is our frictional force. And then since this is the radius of our rotation, if you can still see it, we know that we want our whatever we're hold on. We want to sum up the forces which oh my god, which contribute to this. So when we're looking for the centripetal force, oh my god. Centripetal force, we're really asking how much of these forces that we have is contributing to forces in this along this direction, you know. So we also know that over here we have an angle of beta of, which is 20 degrees. And then we use geometry magic to know that this is 20 degrees. If you guys don't know how to get this, it's because like these are alternate interior angles, which if you would remember parang laws of geometry, they're automatically equal. But in case you forget how it works, you can also keep in mind that if this is 20 and this makes a triangle, this should be 90 degrees. Then angles in a triangle should be 180. So 90 plus 20. This angle is going to be 70. And then you also know that there's a right angle here. Oh, there's a right angle here. So then this other complementary angle should be a complementary angle of 70. So this is 20 degrees. And then we also know that the normal force is going to be perpendicular to the friction force, since the friction is going to be parallel to the surface and the normal force is going to be perpendicular to it. So we know that we should have another complementary angle here, 70 degrees. So actually, since you're already given the normal force, which is 12,760, and the friction force, 5,995, the centripetal force boils down to simply um trigonometry again. Start with the okay, I'll write it in variable first. Normal force times cosine 70 plus the friction force times cosine still, cosine 20. Then it's going to be 12,760 cosine 70 plus 5,995 cosine 20. Then when we solve that, you're going to get 9997.6. Going to be our FC. And then we have our centripetal force. We know that since like F equals ma, that still applies to centripetal force also. So since we want to find the acceleration, the centripetal acceleration, just rearrange this. Our AC is going to be Fc over m plus 9997.6 all over, what's m? 1000 kilograms, which is 9.997 meters per second squared. Then since we finally have our AC, we can substitute it back into this V equals ACR, which is going to be square root of 9.997 times our R, which is 10 meters. Then if you put this into your calcu, you're going to find that it's equal to 9.999 meters per second, which you can round up to something which is delightfully in the choices. A, which is 10 meters per second. Hurrah! So back to another hard item, medyo hard. Number 20, if we're all ready to move on. This one isn't so hard, but sorry. Uh, it shows a certain type of problem which you are not gonna stop seeing in the Physics 770 series. Basically, times when they don't really give many numbers and you're gonna have to deal with just having variables. Like this V naught, we're not gonna solve for V naught because it's gonna cancel out. Sorry, spoiler. Um, okay, so let's read the problem. Objects A and B are launched from the same point with the same initial speed V naught at different launching angles. Theta A equals 40 and theta B equals 60 from the horizontal. If TA and TB are travel times from their launching point to their maximum height, what is TA over TB? So let's draw our setups first. For A, it's 40 degrees. Then the initial velocity. For B, this is 60 degrees and the initial velocity. So some of you, I hope that most of you got it, but when it's asking from their launching point to their maximum height, that's another conceptual thing that you need to know. How do we know that it's at the maximum height? So since in projectile motion, it's usually gonna parabola at the maximum height, that is, oh, the screen is frozen. Okay, that is when, sorry, something that happens when you're at the maximum height is that the velocity is equal to 0. So what we're solving here is the time it will take for sorry, not just velocity, my bad. This is Vy, but Vx is still non-zero because it's constant throughout the whole thing. So we're asking the time it takes for Vy to turn into 0 for both of these scenarios. So one thing we need to know first, Vy, since we're given V naught, which includes both the x and the y component, we need to use our trigonometry trigonometry first. So we know that Vy is going to be equal to V naught times sine theta. Where can I put this? There. It's just hiding there. So let's solve for the initial Vy for both of these. Or not exactly solve. Let's just represent it. So this is going to be V naught sine 40, V naught sine, V naught sine 60. And then EA. So since we're asking the time it will take for them to decelerate, we need to use this formula, which shows that acceleration is equal to v2 minus v1 over t2 minus t1. But then we're just gonna change the v over changing t. We're just gonna switch it around so that we can find out t. So actually changing t, time interval it takes is going to be equal to v2 minus v1 all over a. So let's make our v2 minus v1 all over a for both of these situations. So ta will be equal to v2, which is 0, because that's when its maximum height, when vy is equal to 0, minus our v1, or vi initial. It's going to be sine 40, v naught sine 40, all over negative 9.8 meters per second squared. And then, then our tb equal to 0 minus v naught sine 40, sine 60, all over negative 9.8 meters per second squared. So what you're gonna notice here, what you're gonna notice here is we still can't solve for exact values here because we have our v naught, which is unknown. And I spoiled kanina now. We're actually not gonna end up solving for v naught because what they're looking for is ta over tb. So we just divide these two, or yeah, we divide them. We'll do negative v naught sine 40, 9.8 meters per second squared times 9.8 meters per second squared all the way negative v naught sine 60. So we love to cancel. So the negative 9.8s cancel out and the negative v naughts cancel out. So what we're actually going to end up solving for ta over tb is sine 40 over sine 60. So simple. And then when we put that into the calculator, get 0.742. Which, guess what, guys? It's in the choices. Oh my god. Okay. Who's ready to move on? Because I am. I'm gonna move on. Okay. This is the last of what I consider yung medyo hard na problems. Number 12, which is Ikotoki. An Ikot jeep with constant velocity of 40 meters per second passes by a stationary Toki jeep along a straight road. Immediately, the Toki jeep speeds up at a constant rate of 5 meters per second squared. After how many seconds will the Toki jeep catch up with the Ikot jeep? So the main reason I consider this like a harder problem is you might be tempted to answer 8. Well, let me tell you now that like 8 is the wrong answer. Like, sorry, you might think it's 8 because you're going to see that we have accelerating at 5 meters per second squared and we have the other jeep at 40 meters per second squared. But if you answer 8, you're going to be answering how long will it take for the Toki jeep to be the same speed as the Ikot jeep? But what they really want to find out here is for it to catch up, meaning that the position of the Ikot jeep should be equal to the position of the Toki jeep. So we're going to use our blessed equation, x equals x naught plus vit plus 1 half at squared. So since we have two scenarios here, we're going to be substituting into, basically we're going to have two formulas na ganito that follow this format. It's going to be one for the Ikot, one for the Toki. So let's make sure we know the situations. This is the Ikot, the Toki. So the Toki and the Ikot, they both start. In this case, we're measuring the start at the same point. So x naught equals 0. For the Ikot, its velocity is 40 meters per second. And it's a constant velocity. So we also know that its acceleration is equal to 0. We know for the Toki, we know that it's starting from rest. So its starting velocity is actually 0. Naglalag na naman. Then we know that the Toki is accelerating at 5 meters per second squared. But let me wait for the stream to catch up. Hello. I need to restart it again. Go on. Screen share. Okay. So now that we know this information, this smaller, let's substitute and make our kinematic equations for both of these. So the position of the ecot is going to be equal to 0 plus 40 times t plus 0, because this acceleration is 0. Then x, the position for the Toki is 0 plus 0 also, because its starting velocity is 0, and plus 1 half 5 meters per second squared t squared. So since we know that the position of the ecot, we're trying to find out the time when the position of the ecot is equal to the position of the Toki. So let's just equate these to each other. Simplify to 40t equals 1 half 5 meters per second squared t squared. Then when you put it in your calculator, you rearrange it, shift solve and all that, you can get t is equal to 16 seconds, which you would thank the Lord if you got that answer, because it's in the choices. 8 is also in the choices, but don't answer that. So we're done with like yung medyo hard na items. Before we move on to the rest, I think I'll just mention some general pointers, I guess. So yeah, when it comes to problem solving, let's see, what's a good example? What you want to gonna do first is identify like the given. You know, as much as I don't know about you guys, if you hated like GRESA or GFS, whatever you had in high school when you're solving physics, it is like the right way to go about things. So first find out what you're given, and then what's being looked for, and then list down the equations related to the situation, like related to the given that you have and what you're looking for. And then what can help you do that is use your free body diagram. And then wala na ba akong pointers? General pointers. Think general thing about projectile motion. If di pa siya shrimple sa inyo, another thing we should note about projectile motion is that it's parabolic, right? And then we should also know that at the same heights, like this, the magnitude of the velocity is going to be the same. So like if the velocity at this height is a certain v a or v equals a, ganun, the velocity here is also going to be v equals a. Well, not exactly a. Same magnitude, but different directions. So this is velocity a going upward, and then at the same height later going down, the velocity at that same height is going to be negative a. And I think this might come in handy. I think one of the tricky questions when I took physics LE1, it had to do with like a volleyball. So there was a volleyball, and then the information they give you is that when it reaches the other side of the court, uh, it's a certain velocity. It tells you what its velocity was in the instant that it reached the ground. But we should remember that because of this symmetry of projectile motion, the magnitude of this velocity is actually the same magnitude. It has the same magnitude when it left the ground. So the v here is also equal to a. And then, if I remember correctly, the question they asked here was, how much time does it take to reach the top of the net? So Basically, yeah, it's similar to the ones that we solved. You just need to have the conceptual knowledge to identify that. The speed that they gave here at the end is the same speed. We can use it as the magnitude of the starting velocity. Sorry, wait lang. Na-distract na ako. I think I hear an echo, but that's okay. Uh, Exam pointers, I guess. This Samplex P, it's a lot like the physics exam. Well, it came from NIT, so obviously. And like you might be like doubtful because it's a 2015 Samplex, but I guess they didn't really change their style since then. Um, so yeah, this Samplex is pretty accurate to the actual exam, except that I'm pretty sure nowadays the exams are 30 items, but this one is 40. So if you answer this one, you'll get a ton of practice. Since it's 7:55, I think we can take a short break first because I also need to get some water. Yes. Let us come back at 8 p.m. 5 minutes. Is that okay? Send a heart if that's okay. Let's take a break. And then after the break, I'll discuss the rest of the items. Probably won't finish, but I'll try to get as far as I can. You guys.
Okay, thank you, Jerome. Thank you guys as well for sticking with us for the first hour of the review session. Just one reminder actually. Um, for those who are applying to IE Club, make sure that there is at least one person from your buddy fam who is attending buddy bidding, which will happen, I believe, in 5 minutes. Um, Somebody from Memcom should have sent the link to buddy bidding. So make sure that at least one of you guys in your buddy fam is there. In the case that you'll have to leave the review session, don't worry, there's a recording. The live stream that we sent to the Fast GC is uh, will still be open even after the live stream is ended. So it will basically be the recording. So ayun lang. Thank you so much again for sticking with us so far. Reminder to attend buddy bidding and ayun lang. See good luck with the rest of the session.
Hello. Sana di kayo nagulat. Okay. 801. Please send a react if you're ready to continue. If you're back from outer space. Sige, sige. Thank you for the reacts. Thank you for being here. Wow. I feel like Sabrina Carpenter. What? Okay. So thankfully we did most of the hard items. Wait lang. Is my stream echoing the audio? Yun ba yun? Yun natin. Anyway, so since we're back, and wait lang. I muted. Yeah, I muted it. I'm so sorry. Okay, let's continue with the easy items. So it should be smooth sailing for most of the items since we discussed the hard ones. Aren't you glad we did that? So let's start here. A Campos Tomato soup has a density of 1.05 grams per cubic centimeter. How many grams of soup are there in 5 times 10 to the negative 2 cubic meters of soup? So honestly, I was kind of confused why this item is here, but I think less on sa density siya and more on the dimensional analysis yung tinatest dito. So I think we all know na density is equal to mass over volume. We have the density, we have the volume. So let's get the mass is equal to density times volume. But notice na our density is in cubic centimeters. Our volume is in cubic meters. So we have to convert one of them. And arbitrarily, I would like to convert um the what's it called? The volume, which is the 5 times 10 to the negative 2 cubic meters of soup. So 0 times 10 to the negative 2 meters cubed. And then we just use our conversion factor here. Since we want to cancel the meters, we want to turn it into centimeters. 1 meter is 100 centimeters. And since it's meters cubed, let's cube this. So what you're basically going to be putting into your calculator is 5 times 10 to the negative 2 times 100 cubed, which is 50,000 cubic centimeters. Cubic centimeters. Then now we can multiply like normal. B equals, M equals 50,000 times 1.05. Then we're going to get, I'm going to look for the answer key because I don't want to put into the calculator. Yo, 52,500 grams, which again, we would be so happy to hear it's in the choices. Letter C, 52,500 grams is our answer for number 1. Okay, on to number 2, dimensional analysis na naman. So this is when you might be confused if you haven't seen an item like this before, but again, it's simple lang. They're just gonna give you imaginary units of measure, and then you have to find out the imaginary unit of measure of a certain variable. So x equals y squared over z. So let's make this. Let's replace the variables with their units. So y is L over t, L over t. Then this is y squared. Z is L. It's going to be equal to L squared, L squared over L times t squared. It's going to become, we can cancel one of the L's. L over t squared, which is, hooray, it's in the choices. Oh, it's in the choices, letter D. So yeah, very basic. Basically, you just have to keep in mind that if may equal my equation, dapat the left-hand side and the right-hand side sa end dapat pareho sila ng units. Well, okay. Number 3. Find x, don't ask y. If the x and y axes point to east and north respectively, what is a equals 500 north, 65 degrees west of north in unit vector form? So for me, what I like to do when given vector problems, you make the plane first, and then you draw the vector or vectors. So 509 newtons, 65 degrees west of north. West of north. So this is our north, this is our east, west, this is our south. 65 degrees, 500 newtons. So this is really just, again, a practice in trigonometry and vector adding or vectors in general. So x component is going to be equal to negative 500 newtons times sine 65 equals negative 453.15. Oh, that is squished. Y component was, oops, 500 newtons cosine 65 was 211.31. Then you just remember that our I is the unit vector for the x-axis and j is the unit vector for the y. So find the corresponding negative 453i and then 211j, which is our letter B. Letter B. Oops. Ang daming letter B dito. Anyway, I guess one thing to note is just be careful with your signs. If you're gonna use an acute angle, let's say an angle less than 90, you're gonna be sure now what you get is positive, meaning that you have to negate as necessary. So since you can see here, just based on the Cartesian plane, here, the x component should be negative since it's on the left of the y-axis. And then the y component should be positive since it's above the x-axis. But if you don't want to think too much about that, well, honestly, it's easier. I think this is an easier method. You use the angle you're given and then you supply na lang the negative or positive signs based on its position in the Cartesian plane. But there's also a method that you can use, which is you use the parang absolute angle, if you know what I mean. Well, I'm going to illustrate what I mean. So this 65 degrees, since like in Math 21, usually you measure angles from the positive x-axis, right? So this 65 degrees is actually coterminal with 90 plus 65, which is equal to 135 degrees. So actually what will happen here is if you use 135 instead of 65, when you calculate 500 newtons times sine 135, it's come on, bro. Let me test it out. 500 times sine 135. Sorry, 190 plus 65 is 155. I promise I got into EP. Sine 155. Oh. Okay. Not sine kasi. So when you're using the oh yeah, that's another advantage pala of using the absolute angles. If you're measuring always from the positive x-axis, the x component is going to be cosine, the y component is going to be sine. So we're actually doing 500 newtons cosine 155. You're going to get a good negative 453 without having to multiply your own negative sign like we did before. But it's really up to you which one you think is less confusing. The most important thing is you don't mix up the signs in the end. So this one, This one's fun. It's pretty basic. Basic. So since we're given the vectors graphically, we can also find out its resultant graphically using the head to tail method. So just pick any of these vectors to consider your starting vector. Since it's p plus q plus s, let's just arbitrarily choose p. So from p, let's like connect something which is equivalent to q. So you can see that q stretches 4 boxes on the x-axis and then 2 boxes up on the y-axis. So let's just copy that. So this is our q. Then let's add our s, which is just 3 boxes to the right. This is our s. And then if we pick from the origin toward where our tail to head thing ended, we have our resultant vector. And well, only one of these looks even remotely the same as what we got. So it's D. Number 4. Okay. Number 5. This one's a bit long. Well, yeah. So Vic tour guide walks 100 meters, 25 degrees south of east from the Rizal Monument. He then moves 150 meters, 35 degrees west of north. What is the position of Vic with respect to the Rizal Monument? So let's consider this movement as our V1, this movement as our V2. And then let's do our favorite thing when it comes to vectors. Let's graph it. Like obviously the graph doesn't have to be super accurate as long as you yourself understand what the graph is saying. So that's our northeast, northeast, west, and south. So let's start with V1. So 100 meters, 25 degrees south of east. So south of east is here. 25 degrees is 100 meters. And then our V2, wait, sorry, V1, V2, 150 meters, 55 degrees west of north. So something like that. 55 degrees, 150 meters. So what we're gonna do, since it's what is the position of Vic with respect to the Rizal Monument. So it's basically asking what's the resultant vector? What is V1 plus V2? So since these are like, they are not perpendicular nor are they parallel, we can't just add 150 or add 100 or anything like that. So the best thing we can do is decompose both vectors first into their x components and their y components, add the x components, add the y components, and then we will have x and y components. Wow. Okay. So let's start with V1. So its x component is 100 meters times cosine 25. Kasi, yeah, the 25-degree angle here is adjacent to the x-axis. And then 100 meters sine 25. It's going to be equal to something like 9.63 up to 42.26. V2, on the other hand, its x component is 150 meters. Sorry, for this one, for V1, we're going to add our own negative sign because we see that it's below the x-axis, so we know its y component is going to be negative. Since we're using the acute angle, we have to supply the negative sign ourselves. And then same for here, the x component of V2, we see it's on the left side. So we're going to supply our own negative sign times sine 35. And the y is 150 meters cosine 35 equals a negative 86.04, 122.87. And then we're just going to add the x components and the y components together. So x 90.63 minus 80, what the hell? 86.04, y negative 42.26 plus 122.87 equals 4.59 meters, 80.61 meters. This is east, this is north. Another thing to note, when it comes to vectors. The signing isn't strict as long as you yourself track it also. But the convention is east or to the right is usually positive, and then up or north is usually positive as well. So if you want to follow those, then yeah, you can. And I would recommend following the convention so that um, you're able to follow most solutions more intuitively also. So since we ended up here with a positive value and a positive value for both x and y, we know that it's east and we know that it's also north. So let's just find the corresponding answer and hope it's in the answers, which is 4.59 east, 80.6 north, letter A. Ano pala, if you guys have already gone through the samplex and you have like an item, a request item that we go over, don't be shy to send lang sa chat because we don't have enough time to cover everything. So if there's something you want to be discussed, just say the words. Okay, this one is Shrimple, I believe. The plot in the figure is the position of CT. I hope you guys know who CT is. Actually, we're not even that much of an age difference, sorry. As a function of time, at which of the following time intervals is the average velocity of CT greatest? So you'll notice that the average velocity, the time intervals given, they all start at t0, t naught. So thankfully, that's going to make it a lot easier to analyze. So since average velocity is just average velocity is just uh displacement over time. Uh, when given a position time graph, it's actually just the slope of the line from a point to the origin. So ayon, you're making these lines. So this is a line from T0 to T1, T0 to T2, T0 to T3, T0 to T4. And then since they all start at the same point, um, and then the slope is the average velocity, it's really easy here to see which has the highest slope, which is basically the steepest one, which is going to be this one, which is the average velocity from T1 to T0, letter A. Ah, okay. Number 7, the run. A runner covers a distance of 50 meters in 6 seconds to move from x equals 0 to x equals 4. What is the average speed of the runner? So this is also easy, but it's basically a concept check if you know the difference between speed and velocity. Oh, sorry about that. Oh, okay. Sorry about that. The average speed is just going to be distance over time. Okay, sorry, that's really ugly, but you get the point. Velocity is displacement over time. And I'm going to assume you all know that, but if you want me to explain it, chat na lang. So the displacement here, that we don't need to know it. This x equals 0 to x equals 4. It's telling us the displacement, which is 4 meters. But since we're looking for speed lang, we care about the distance, which is 50 meters. So speed, 50 meters. Oh my god. 50 meters over 6 seconds. Number 6, just punch that into the calculator. You're going to get 2.5 meters per second squared. Huzzah. It's in the choices. Then the next item. Sorry, I moved on pretty quickly, but I think that's a pretty easy item. The hardest part is just knowing the difference between displacement and speed. So 8, the ball of banality. A ball moves in a straight line. Its velocity is 10 meters per second at t1 equals 3 and stops at t2 equals 8. It's the average acceleration from t1 to t2. So let's start with listing down our givens. Its velocity at t1 Let's put the 10 meters per second. And then T1 is equal to 3 seconds. Our V2, they don't explicitly state it, but they told us it stops. So we know our V2 is 0. V2 is equal to 8 seconds. So average acceleration is just change in velocity over change in time, which is going to be 0 minus 10 all over 8 minus 3. So we're going to get negative 2 meters per second squared. That's our letter D. Ang galing. Ang dali. You guys got this. Una niya na yan. So, number 9. The position versus time graph shows the motion of a particle in one dimension. At what point on the graph is the instantaneous speed the greatest? So, again, we're using the concept na given a position time graph, the slope of the graph, in this case, since instantaneous speed, it's going to be like yung tangent line. But since linear naman lahat ng parts, it's just the slope. So we observe the slope here. And then you kind of just have to look. There's no calculating again. You just look at the graph, and you're going to know that A is going to have the steepest slope. So that means it has the greatest instantaneous speed. Yung. Number 10. Ew. Which of the following graph represents the position time graph of a car that travels toward the positive x direction at a constant speed, stops, and then moves in the opposite direction at a constant rate? So let's look at our letter A first. Moving toward the positive x direction. Yes, it is. Then it stops. Yes. And we also, going back to moving in a positive x direction at a constant speed. We know it's at a constant speed because the graph is linear. But like if this was the position time graph and it wasn't linear, that means the speed is not constant. Yeah, that's just something to note. Graphical interpretation. There's a fair amount of items that make use of it. So then it also goes on the opposite direction since it's going down at a constant rate, linear again. So actually, letter A na yung sagot here. But let's go over why the other ones aren't. This one, letter B, it's pretty close. It goes up at a constant rate. It does stop here, and then it goes on in the opposite direction. But the weird part here lang is this part. It changes position in 0 seconds. So like it teleports. So since as far as I know, we don't have any car that teleports yet. We can't say that B is our answer because it's just not possible. So same thing here, just teleport. And then also it doesn't stop. Walang part where it stops. So it's wrong for 2 reasons. This one pretty close but opposite direction. Okay. Number 11. A snatcher is running along a straight line with a constant acceleration. He covers a distance of 70 meters in 8 seconds. If he started from rest, what will be his speed passing through the 70-meter mark? Hold on. Okay, let's start listing down our givens again. I love givens. So B equals 70 meters. Then the time he does that is 8 seconds. Start from rest, what will be his speed passing through the 70-meter mark? So what is his speed? His final speed, basically. F. Okay. And then he started, also says started from rest, so we know our other given is V naught equals 0. So we're going to use the blessed kinematic equation. This will be IT is 1/2 AT squared. And then substitute. When we substitute what we have, 70 meters, which is the final x. And then our x naught is considered 0. Then our vi is also 0. So plus 1/2 a 8 seconds squared. So basically what we're solving here is for the acceleration. We're going to get acceleration equals 2.1875 meters per second. Great. I'm sorry, I forgot to mention the reason we're looking for acceleration first basically is we know he started from rest. We want to know his speed at the end. And we have that fun equation, Vf equals V naught plus AT. But since we know the T already, we know the V naught, we're just looking for the A. That's why we're solving for the A. And now we have it. So let's substitute what we have into this equation. When you calculate it, you're going to get Vf equals 17.5 meters per second. It's in the choices. Okay, number 12, we discussed that already. Number 13. So here, what is an object we're taking at equal time intervals? Which of the following best corresponds to an object freely falling from a certain height? Oh, from a certain height above the ground. But let me put the screen back up. So what you're gonna inspect here, since you're basically given nothing else to inspect except the distances between these. So since these shots are taken at equal time intervals, what you're basically inspecting is how much distance did it travel in equal time intervals. So here, oops, in letter A, they all have equal spacing. That means that its velocity, downward velocity, was constant. But we know that when something is freely falling, it has acceleration due to gravity. So its velocity shouldn't be constant. So it's not A. And then B is just like a weirdo item because it's equal, it's like symmetrical. At the end, the interval, the distance traversed becomes small again, which is weird. So not really possible unless there's other forces acting. So it's not free falling. So here, what actually happened here is it's moving fast at the start since it traverses a lot of distance, but then the distance it traverses gets smaller and smaller. So it's actually slowing down as it falls, which is not a characteristic of free fall. And here is our right answer, where the distance it can traverse between equal time intervals becomes greater and greater because it's speeding up. Answer here, letter D. Whew. Okay, we answered Deadpool already. Okay, take. It's gonna take a water break. Let that sink in. Okay, ready to continue? I hope so. Okay, number 15. I actually think this is a bit of a tricky item, but I didn't include it sa kanina. So starting from the origin of some coordinate system, a chicken moves 2 meters to the x direction for 2 seconds, then 3 meters to the y direction for 3 seconds. What's the average velocity for the whole motion? So if you're like in a rush, you might be wanting to already get the resultant, get the resultant vector, ganun, ganun, blah, blah, blah. But you should make sure first, before you do all that, before you do all that, check the choices. Because sometimes the choices are given like this, decomposed. So, well, except for C, decomposed. So when it's decomposed, chances are, di mo na kailangan recompose, whatever the word is that for that. So what we want to do first is just identify our displacement vector. which is going to be 2 meters I plus 3 meters J. And then average velocity for the whole motion. So that's just our, our displacement vector over the time it took. And then our time, it's not 2 seconds, it's not 3 seconds, it's 2 plus 3 seconds, which is 5 seconds. So just divide this entire vector by 5. So we're going to get 2/5 meters per second I plus 3/5 meters per second J. Kaya our answer here is in the choices. It's letter A. Thank you. Number 16, another conceptual, not no calculation at all. So given the velocity and acceleration of a particle as shown in the figure, which of the following statements is true about the particle's motion? So you see that the velocity here, it's going to the right, straight to the right. And the acceleration is at this strange angle. So something you can do here, decompose this acceleration vector first into the cardinal axis so that it's easier to deal with. So we know that this acceleration is actually made up of an x-axis acceleration and y-axis acceleration. So from here already, you can, if you're quick, you can tell that it's slowing down and turning south. Actually, you don't need to be quick. Yun na yun. So it's slowing down because this velocity, its velocity is to the right, but the acceleration is opposing that because it has a negative x component. And then turning south because there's a component of the acceleration pointing to the south. So basically, I just traced the graph many, many times. I hope you guys understand that item. And then number 17. In a testing site, a satellite moves such that its position with respect to the origin at any given time t is given by the function r of t equals, yeah, I'm not going to read all that, but you can see it. So all the quantities above are expressed in SI units. What is the magnitude of the satellite's acceleration? So one common mistake that you might pull here is that if you're, sorry, let's go back to this equation first. X equals x naught plus vit plus 1/2 at squared. So you're going to know the quantity associated with acceleration is the one which is going to be next to t squared, since this is basically sorry. Basically, this is x of t. So you might be tempted to think, oh, this 3 is next to t squared. This 4 is next to t squared. So that's the acceleration. You're gonna be like, oh, let's do 3 squared plus 4 squared. Well, I don't know. I can't speak for you, but that's a common mistake is all I'm saying. That's wrong because you have to note that this is 1/2 at squared. So actually, 1/2 of the acceleration along y is equal to 3. And 1/2 of the acceleration along z is equal to -4. What you want to do first is solve for the actual accelerations, just times 2. Ay equals 6, az equals -8. Then we're going to get our resultant acceleration. Now you can do 6 squared plus 8 squared. It's going to be like square root of 100. You're going to get 10 meters per second squared. That's the answer, 10. And if you did it the wrong way, you're going to get 5. But again, that's wrong. So the answer is 10. Another way you can solve this is Math 22 style. Actually, not 22, Math 21 style. Acceleration is the second derivative of the position, but I'm not sure if andun na kaya. So let's say you get the second derivative, it's going to be 6 and then 4. 6j, 4k, same thing that we got kanina. So yeah, there's 2 ways to do that one. But I won't do the other way too much because I don't know if you covered that already. Number 18. Oh, sorry, we did that already. Number 19, number 20, number 21. Mahabang maiksi. A small sphere is sphere. Small sphere is tied to string and is made to move in a circle with constant speed of 5.30 meters per second. How long must the string be for the sphere to have a centripetal acceleration of 8.40 meters per second squared? So as soon as you see this centripetal thing, we're gonna pull out that formula. AC equals V squared over R. Take a sip of water. This one's a pretty simple item. Just make sure that you can properly identify your givens. Constant speed of 5.30 meters per second, that's our V. And then what we want is a centripetal acceleration of 8.40 meters per second squared. So just rearrange and substitute. You know that how long the string must be. So you know that this is like our situation here. This is the string, it's the sphere. So that means the string acts as the radius. So we're asking how long should the string be? We're asking what should the radius be of the radius in AC equals V squared over R. So let's rearrange. R is equal to V squared over AC. Since we have both of these, substitute. Put it into your calcu. You're going to get a number, which is 3.34 meters. That's letter D. Hope this helps. Number 22. Grabisha. An adventurous cockroach lies on the tip of a 0.4 meter blade of a ceiling fan. If the fan rotates with a period of 0.3 seconds, what is the centripetal acceleration of the cockroach? So, yeah, centripetal acceleration again. So we have this fan. Since fans go in a circle, in a circular motion. I hope that looks like a fan to you guys. The length of the blade is actually gonna act as our radius, 0.4 meters. And then the cockroach is like here. So sorry, let's pick up our AC. Okay. They're giving us the period. So you're gonna use this other formula, which it should also be in your formula sheets. So no, don't worry about memorizing this because I honestly don't memorize this either. I just saw it in the formula sheet. So it's like, okay, good to go. We know our radius is equal to, the formula is 4 pi squared r over t squared. So our radius is 0.4 meters. Our period, they gave it directly, 0.300 seconds. So ayun, substitute mo lang. You're gonna get 175.46 meters per second, which is in the choices rounded to the highest, to a whole number, 175 meters per second. Okay, number 23. It's been a long day. Sorry. From an intersection, you move east while your friend Brian moves north. So I'll start drawing this intersection. If you and Brian maintain the same constant speed, which of the following is true about Brian's velocity relative to you? This is the 2015 Samplex, but parang I remember answering this in our own LE. So baka it's a resident question. So Brian's moving north. This is Brian. Then I'm moving east. Or we are moving east. This is us at a constant velocity, constant speed. Which of the following is true about Brian's velocity relative to you? So off at the get-go, I think we can eliminate A and B. Because we know that we're both moving at constant speeds, constant velocities. So, and same direction, constant direction, so constant velocity. So there shouldn't really be a reason why the relative velocities would be changing. So eliminate A and B right away. So we just need to know, is Brian's velocity directed northwest or southeast? I think this is also pretty obvious. So if you want to eliminate, it should be south. It shouldn't be D. There's no reason for it to be D. But just to finish the explanation, since we're going to the right, we are going to the right, but Brian isn't moving anywhere relative to the x-axis. He's just going up. So as we go to the right, to us, it looks like Brian is going to the left. Kaya, ayun, northwest. And the north part is also, that's a given because he's already going north. And we are not moving along the y-axis, but Brian is moving north. 24 blown by the wind. An airplane's velocity relative to air is 240 kilometers an hour, 30 degrees east of north. If there is a 100 kilometer an hour wind from west to east, is the magnitude of the airplane's velocity relative to Earth. So this is, it has to do with relative velocities, but when you break it down, it's really just a vector addition again. So let's draw our vectors first. So this is relative to the air. I guess something to note, just so you're sure that you can place wind on this graph, just remember that wind is like moving air. So let's start with the airplane first then. 3 degrees east of north is 30 degrees, 240 kilometers an hour. Let's add our wind, which is moving air. Okay, we're putting it in this plane, which is our initial frame of reference, which is the air, which is kind of weird, but you know, it's true. 100 kilometers an hour west to east. So let's label our axes so we don't get confused. So we're just gonna get the net velocities, adding up the vectors. Since this is 30 degrees, going to be doing more trigonometry. Dx total is equal to 240 sine 30 plus 100 is the wind that we added. And you should get 220 when you put that in the calculator. And the total along the y is equal to 240 cosine 30, which when you put that into calculator too, 207.85. Oh my god, 7.85. And then we have the x component, we have the y component, but again, look at the given. They are not in component form. So we have to make them into one resultant vector using this, the thing where you do the square root of x squared plus y squared. It will be x total plus by total squared. Then you substitute, you just use these values. When you do that, you should get 302.65 meters per second. Guess what? It's in the choices. So if all goes well for you guys, all your answers will be in choices, hopefully. And then, so we go to number 25. This is conceptual again. No solving. Which of the following best explains why astronauts on the moon jump higher on Earth? They weigh less on the moon than they do on Earth. Their mass is less on the moon than on Earth. The jumping force is greater on the moon than on Earth. Or the acceleration due to gravity is greater on the moon than on Earth. So let's just eliminate first. So their mass is less. I'm sorry. This is like the most obviously wrong one because their mass should be the same. Because that's like yun yung laman nila. I think you all know what mass is and how it's different from weight. And acceleration due to gravity is greater on the moon than on Earth. This is not true. And if it were true, then it would actually, you would actually jump lower on the moon. And then jumping force. This one, it's just not always true because like it's up to them how high they jump. But and, being on the moon and being on Earth shouldn't change your jump force or like your strength. So the answer here is that they weigh less on the moon than they do on Earth. Because yeah, the difference between weight and mass. Weight is just mass times acceleration due to gravity. And since the g on the moon is different than the g on Earth, you do way less on the moon than you do on Earth. 26. Newton's apple. Which of the following scenarios describes an object in equilibrium? 1. An iPhone 6s falling off a tree. MacBook Air at rest on top of the table. iPad Pro sliding at constant speed down a rough ramp. So iPhone 6s falling off a tree. That means that the gravity the force of gravity is acting on it. Kaya, wag na yan. It's definitely not one. Then Mach air resting on top of the table. Yes, because it's at rest. So agad-agad that's at equilibrium. That's number three is the one na ito yung confusing sa item. And honestly, like it's still confusing for me. It's a bit hard to say. Kasi I don't think if they have a problem like this, I hope they phrase it better. Kasi the problem with this is if it's so rough na parang it's bumpy, what will happen is as it goes over the roughness, it actually changes direction even slightly. Kaya it would have a change in direction, which is an acceleration, which would be not an equilibrium. But in the case na the roughness actually has nothing to do with the terrain somehow, and the pathing will still be straight. This actually, since at a constant speed, that means its acceleration equal to zero. And since it should just be going downward, the direction is also constant. Then in that case, it would also be in equilibrium, meaning basically this would mean parang the weight which was pulling it down is cancelled out by the friction of the ramp. So if you ask me, it can be either of these. Um, it just this problem itself needs more clear wording. I hope you guys get why. Okay. Number 27, the frame. You are riding a car that moves in a horizontal line. At what time interval is the car a valid inertial frame of reference? So let's review what's a valid inertial frame of reference. Basically, if you want to have an inertial frame of reference, that frame of reference itself should not be accelerating, or basically it should be at equilibrium. So since this is the velocity graph, we can observe that if the velocity is changing, that means there is an acceleration. Also here, the velocity is changing, decreasing. This is the only part where the velocity is constant. And if velocity is constant, that means acceleration is equal to zero. Kaya interval 2 lang yung valid. Letter B. Okay. 28, another fundamentals. Which of the following is the correct free body diagram? So let's just review. The weight, it should always be straight down. And then the normal force should always be perpendicular to the surface, which is exerting the normal force. And then assuming that this brick is going to be sliding down the ramp. So this is where it's going to be moving. This is the velocity of the brick. Friction is always going to oppose the direction of movement. So this is where our friction is, opposite of the velocity. Please note that this velocity I drew is not part of the free body diagram. Velocity for reference lang yan. So this is our normal force, this is our weight. So let's just pick which one looks like it, which is letter A. So number 29, Newton's law. This is conceptual again. Car is moving in a 2D plane as shown in the figure. It increases its speed from rest in segment 1, moves in a constant speed in segment 2, then moves in a curve at a constant speed at segment 3. Which segment are the acceleration of the car not zero? So here in interval 1, it's increasing its speed, so its acceleration is greater than 0. Then here, it moves in a constant speed in a straight line, so it doesn't change direction, it doesn't change speed. A is equal to 0. Then here at this curved part, although the speed is constant, since it's curving, the direction is changing, so our A is not 0. Just from that, you can answer that it's D. 1 and 3 only. Okay, kapareha. Consider the block of mass M accelerating on the rough ramp with a magnitude of A. As shown in the figure, which of the following is the reaction force of the weight of the block. So conceptual again, no calculation. Let's go through the choices. Mass times acceleration. I think your instructors have emphasized that this is not a force because this is MA. MA is not a force. Um, so let's move on to frictional force by the wedge to the block. While this is sorry, so this is going to be the frictional force. This is a force, and then because action reaction forces, they should not be acting on the same object. The action force is acting on a different object than the reaction force. So the weight of the block, it's the block acting on the wedge. As you can see here, it's on contact with the wedge. So although the frictional force is the wedge acting on the block, this isn't in reaction to the weight of the block. So it's also not B. C, normal force by the wedge to the block. This is the answer. Yay. Basically, generally, I mean, not generally, like overall, normal force is a reaction force to the weight of an object. If I, yes, yes, yes. Because so the normal force is exerted by the wedge because the block is exerting its weight on the wedge. Ayun. That's force exerted by the block on the earth. Medyo random lang to. Doesn't really make sense. It's another panggulo na question. Eh, question? Panggulo na choice. Because in the first place, our reaction force should be acting on the block, not on the earth. So number 31. Quits na. A 25 Newton force directed north is acting on a 10-kilogram crate. What must be the magnitude and direction of a second force on the crate to be in equilibrium? So very, very quick. 25 north. You just know when an equilibrium, the concept being tested here is not equilibrium, is when the forces add up to zero. So just add this, pick the same magnitude, opposite direction, 25 newtons south. Letter B. Let's finish this. 5 newtons, 25 newtons. Okay. Elevator. Okay. Ella with mass 50 kilograms is standing inside an elevator going up. The normal force of the floor on Ella is 755 newtons. What is the magnitude of her upward acceleration? So this is when we're going to use this important formula, F equals ma. And then what we want to do is, since we're looking for the acceleration, we know the mass. We just need to find the net force. So it's going to be like this. Normal force equal to 755, and then the weight of Ella. So that's it. There's no forces along the x. The F net is equal to 755 minus the weight of Ella, which is 50 kilograms, times 9.81 meters per second squared. Put that into a calculator. You're gonna get, okay. So since it's F equals ma, we can directly say that this left-hand side is equal to ma. We know m already. It's 50 kilograms. So transfer mo lang yung 50 kilograms or i-shift solve mo to. You're gonna find that A is equal to 5.29 meters per second squared. Which is, guess what? 10 choices. Kind of funny because yung ibang choices, it's so far. There's 265, there's 77. I'd be kind of terrified if I was in an elevator that fast. Okay. Number 34. He got one job. Your absent-minded instructor accidentally placed a 15-kilogram box on top of a frictionless incline. Did the instructor apply a force of 20 newtons parallel to the incline as shown in the figure? What is the resulting acceleration of the box? This is another problem where we're going to use F net equals ma. Ooh. So let's make our free body diagram of this. It's going to be, this is the 20 newtons the teacher is applying. It's the normal force. Oops. Okay, normal force. Then this is the weight. Weights. Okay. Then let's make this is our dotted line is representing the surface. That's just 10 degrees. So what's that? The jumbo yan, which is also 10 degrees. And you can rearrange the free body diagram to show na 10 degrees. Wait, this is the normal, oops, the normal force. This is the force being applied. So since you just want to know the resulting acceleration of the box, and you know na it's on the platform, the surface. Di naman yan lilipad. So the it's in the yeah, along the y-axis, it's in equilibrium. So let's just focus on the x-axis, which we're going to add 20 newtons and then subtract the portion of the weight which is going in the opposite direction. So we're going to do trigonometry. W sine 10 equals MA. And then we're given the weight, so we already know na the weight is equal to 15 kilograms. 5.8 meters per second squared. So I plug in mo lang yan. We know all of these except for acceleration, and that's what we're looking for. You're gonna get negative 0.3702 meters per second squared. So that's the main challenge, not really challenge of this question, is making sure you know how to keep track of your signing conventions. So we got a negative, and since we know we're treating our positive as uphill, we know negative means downhill. So our answer is a negative 0.3702 meters per second downwards. Ooh, malapit na matapos. 35 hashed 5. Marley slides face first on level pavement, showing his speed uniformly from 2.6 meters per second to a stop for 1.2 meters per second. If Marlowe is 41 kilograms, what's the magnitude of the frictional force? So frictional force might seem kind of random here, but since he slides, or basta the interpretation of this item is that the frictional force was the force used to slow down. So we just need to find, since F equals ma again, we're looking for the frictional force. We know the mass. Let's find the acceleration. So from v1 to a stop, which is 0, we're using the v2 minus v1 over t2, or change in t, rather, for this case. 0 minus 2.6 over 1.2, negative 2.167. Then if you plug in everything we have into F equals ma, we're going to get the force is equal to negative 88.83 newtons. Then since it's just looking for the magnitude, we don't have to worry that we got negative. Just answer D, 89 newtons. Okay, this one. Oh my God, ang lapit na mag-ano. I think, sorry. Our item 31 po isn't the weight. Oh, sorry, I didn't see this 5 minutes ago. M31 isn't the weight caused by Earth's gravity. So as a reaction, the block's gonna exert a force to the Earth. Sounds arbitrary, sabi ng prof namin, but it actually is true, albeit minimal. The weight caused by Earth's gravity. Okay, wait lang. Force exerted by the block on the Earth. Okay, I can read you on. Sorry. Okay. Tama yan. Si Jim Noong Jim yan. Kaya pala ganun yung the old answer key. It had some mistakes, but I guess this was not one of the mistakes. So the right answer here is actually D. Kasi, yun nga, don't follow my example na got tricked. So since we're treating our action force as weight of the block, dapat this is the Earth acting on the wedge. So what we're looking for now is reaction, which should be the wedge acting on the earth, not this. So our new answer, the correct answer is letter D, force exerted by the block on the earth, which it might seem like it's not really exerting force on the earth, but no, parang na-transmit siya through the wedge, from the block through the wedge to the earth. Ang galing mo, diba? Diba? Okay, yeah. That's because it emphasizes na it's talking about the weight here, not like the force that the block exerts on the wedge. If it was asking, uh, what's the reaction force of parang the force that the block exerts on the wedge, that's when the answer is C, the normal force. But since we're talking weight, the specific use of the term weight, tama si Jim, na it's talking about the force exerted by the earth on the block. And then, if okay lang, let's try to extend since 3 items now, then we can finish. I hope that's okay. But yeah, feel free to leave. A box initially at rest on a rough floor is pushed with increasing force until it starts to move with constant velocity to the right. Which are the possible values for the coefficient of static friction and coefficient of kinetic friction? So the thing about this is actually yung start is like, we don't really need to know that. Because in general, the static coefficient of friction is going to be greater than the dynamic coefficient of friction. So, ayun siya. Letter C. It's the only one where the static is greater than the kinetics. But if you just want to interpret it, it basically means to say that it takes a lot of force to break through its state of staticness. But then after that, you can just keep going. Kaya the static coefficient is higher. Atak. 10-kilogram block is resting on a horizontal floor. It's pulled by a horizontal force with a magnitude of 70 newtons. What is the coefficient of static friction between the block and the floor if the block is on the verge of moving? So on the verge of moving basically means the friction is canceling out the applied force. So let's write out our thing. It's normal force, friction. Then this is our applied force. Just the weight. Okay, summation of forces, Fy equals n minus W, Fx equals 70 newtons, the applied force, minus the coefficient of friction times the normal force, which is the frictional force. This is the formula for frictional force. I hope you guys already knew that because we've been talking about friction for a while. This also equal to 0 since, okay, x equal to 0 because on the verge of moving less. And then this one equals to the y equals to 0. The f of y along 0. Sorry, f of y is 0 because it's not flying. It's just on the platform. Ayun. So we can just solve na n. Sorry, not n. Let's use f of n for consistence of formulas. F of n equals w, which is equal to 10 kilograms times 9.81. And then we substitute this back na 70 newtons minus this times f of n, the one that we got kanina, equals 0. Put this in your calculator. You should just get na this coefficient of static friction, 0.7136. Okay, now Rudolph. Ito na yung last item. Ang galing. Rudolph pulled a 55-kilogram sled over a snow-covered ground. If the coefficient of kinetic friction is 0.15, what's the acceleration of the sled if the tension in the rope is 150 newtons? So you might don't get confused by when they talk about tension in the rope. That's basically just Rudolph. That's Rudolph's pulling force. 150 newtons. Weight. And then there's, oh my god. Weight. And then there's friction. the normal force. So this is basically similar to the previous problem. You just need to do your summation of forces properly. Fx 150 minus Fk equals Ma Fy and minus W equals 0. Okay. Oh yeah. Here we do Ma instead of equals 0 because we know it's accelerating. We know that it's not at equilibrium. Then so we can solve now our normal force is equal to the weight. And then we also know that our frictional force is equal to the coefficient of friction times the normal force. And then since we're just solving for the acceleration, let's rearrange this formula. Acceleration equals 150 minus f of k, which is mu of k times n, which is the same as the weight. So now we have all of this in terms of things that we know. Then substitute our given, because our mu of k is 0.15. Our w is equal to 55 times 9.81. Then our m equals 55 kg. So when you substitute and solve, 1.256 meters per second squared. And ayun. Answer is letter D. And we actually managed to finish the whole samplex with a bit of overtime. Thank you for coming. This, if you would like to say any closing words or if anyone has any questions, pa. Thank you for the correction, Kanun. Go on to you. Oh, I'll stop streaming.
Hello.
Yes, yes.
All right. Thank you. So, hey, breathe in, breathe out. Thank you guys for sticking it out. To the ones who are left, thank you guys for staying the whole 2 hours. I hope that you guys were able to learn something, and hopefully we have helped you prepare for your exams way better. So, ayun lang. Thank you so much again. Expect more from us very, very soon. Again, our goal from academic engagements is to cover all the major subjects that you guys have. Well, not necessarily major, but I guess the more difficult subjects. So, goal talaga namin is have review sessions for all the Math 21 exams and all the Physics 71 exams. So, we will try our best and we hope to see you guys there. For documentation lang, we would like to request if for people who can to please turn on their cameras just so we can, you know, so I can send the documentation to the people above me because I have to report to them. Ayan lang. And thank you once again, Ted Jerome, for uh, doing effort tutoring the whole review session. Uh, ayan. So if you guys can, please turn on your cameras. Sorry, bagong gupit. So, all right. Okay, let's go, guys.
If you can't on cam, just send a reacts. Thank you.
Sige. I think that works na. Ayan. So, I'll take the pick na. I think that's fine. I'll take the pick na. Sige. So, uh, turn your cam on or react. And then, I'll count. 1, 2, 3. Kasha naman siya in one screen. So, we're now good. Once again, thank you guys for coming. The recording, you can access sa may link na sinend namin. See you guys again, hopefully. And that's it from us. Good luck in your first exam. Many more this sem, pero hopefully one at a time. Kakayanin nyo yun, for sure. Sige. Good night, guys.
Thank you.